All right, so just continuation from the stream that accidentally ended last time. So we're talking about the Express file upload here, and as you can see, Express file upload does have a vulnerability online, and we found it right here. And what we are trying to find here is how to run this exploit now that we've verified that it actually works. There is a GitHub page with the exploit here that we can go to. Thanks, BT. I'm not sure what happened with that live stream earlier. So if you're just back, let's just finish this and then we'll figure out what happened earlier. But thanks for joining back. Our stream accidentally ended, so we found a vulnerability for Express file upload, and let's see. And this is the GitHub page for it. Thanks, Jupiter. All right, let's just move on from that one. And this exploit here does explain it. So if you look on the victim tab, we have a web server, we have backend, and this looks exactly like what we were looking at. The JS does have Express file upload here. So we know we're actually working with the same exact thing. So in the GitHub page for the exploit, let's go ahead and start the download the exploit here. So this is the Python. Let's try to understand what's happening with this exploit so that we can actually finish with it. It's running a command and it's starting with bash, then the IP address of the attacker, then it will print starting attack, then it will send a post request to the server. We know that our server is listening on localhost, so we need to either send that through a tunnel, or we can run this directly on the victim. So depending on which one, which way we want to do it, we can run this on the victim. And then it's also sending another get on the local host here. So let's go ahead and just download this to our victim. That way we have it. So instead of running it directly on my victim, I'm just going to download it to my Kali first. Once I download it to my Kali, then we can see what's going on with it. So just as a quick reminder, this is the exploit that we want. I guess I can use wget for that. Shouldn't matter. So in the temp here, we can do a vi exploit dot py. I'll do exploit1.py. Then insert. Then just get all this exploit here. Shouldn't matter. Let's edit our exploit. We have been very comfortable editing exploits, so this shouldn't be a problem for us. First, we need to do 38. What is our Kali IP again? (162). All right. So we have to decide, do we want to run this exploit from here or do we want to run it on the victim? I would like to run it directly on the victim if I can. So I will just come here and say, which Python? Does the victim have Python? Yes. Python 3. So I'm just going to run the exploit directly on the victim instead of running it from my machine. So to run it directly on the victim, I need to put the address here. Was it on the victim is listening on localhost. All right, that's all I needed to change there. Python 3 minus module http server 180. All right, so now I can go to my victim and download it. Let's go to the temp wget http 192.168.38.162 exploit 1.py. All right, so we now have our exploit on the victim machine. Now we need to just do is it Python or Python 3? I think it's Python 3. So when I run this, it should call back to me. So I need to let's get our exploit one. It's calling back on port 8020. So my netcat needs to listen on port 8020. On 8020. All right, now that it's listening, let's see if we can run our exploit. So it's Python 3 exploit 1.py. It should say the exploit has been ran, finished. Back here, we're in as a new user who, if we do an ID, has some pseudo privileges that we can see here. We also see LXD. LXD allows us to actually get root privileges. We need to try that one, but pseudo first, because pseudo is easier. What is this pseudo privilege that we have? So we see np, m, and node. So right away, we go to GTFO beans. And as you can see, I just went to GTFO beans and I searched for node. IO. It's a pseudo privilege, so we just click node sudo, and this is what node says to do. Run the sudo. You can specify the user or whatever, but this should work. And it looks like it did something. ID again. We're now root. So privilege escalation, there's nothing to do there. Getting into this machine was where we had the most. All right, so here's the root flag. We owned the machine. It was kind of interesting, especially dealing with the node application. But as you can see, it's a very easy machine once you get in, especially with these pseudo privileges here. Again, check for what's running, what's in the source code. Then once you do some research, in this case, it was a dead giveaway because the source code, you had a file upload tool that was required, which you had to go and look at. Okay, so now let's look at security onion. What did we do? How much noise did we generate? First, let's just refresh this. Now we can investigate ourselves. What did we do to cause a lot of noise? All right, so we have some web server stuff. 227. This is probably from Nmap, Nikto, or any other tools that we used here. And of course, the user agent was Nmap that was set up. I'm just going to look for my reverse shells. Since I was encoding things, I'm curious what that looks like. So we can go and search right away in the Discover. This shouldn't take too long if you're using SSDs, but in this case, so let's see, what did we do? Star.port. Let's look for the last port that we actually did from the exploit here. you notice that this exploit was using port 8020. Let's search 8020 first, because that one was not encrypted. I don't even need to specify parameters. Kibana will understand this. All right, so you will notice right away we see few instances where that port was called in place. So we can tell that we were capturing our attack traffic. In this case, this was destination port. And what was this one? These are mostly bro events, just showing us, hey, you connected to this port. Actually, this one is a signature. Let's check this one. All right. Here's me writing the export term. So we can tell that the reverse shell that we sent from our victim machine was captured in plain text here, mostly because we're not encrypting anything, of course. So this one we can see. Let's search for 4242. What's up, Ramesh? All right, so here's again the one for 4242. Oh, these are just Zik events, but this one is interesting. Yeah, they're just broken events. All right, so if I want to see the traffic for when I sent the payload with the user agent of Chronos, I don't know what the user agent is called. So I'm going to put stars here. I know it's http.useragent, but since mine is, this is not encouraged in a production environment, by the way. You don't want to be putting a bunch of wildcards in your system. This takes forever. So when I sent all the requests as a user agent Chronos, you can see that this is what was happening when we were setting up our user agent as Chronos. And most of these are Zik events. I was hoping to see a Surikata event. And these are all http.logs. So what I think happened here, the reason why we are unable to see our initial reverse shell when we went through the browser is because, remember, we had to run a base 64, base 58 encoding. So when we encoded our traffic, we made it such that it's not, this security onion is unable now to read that traffic because it was encoded in base 58. So we can see because we ran the base 58 encoding. So that's what happened there. That's why we cannot see our first reverse shell. But this will be an indicator that we're actually messing with this using the HTTP agent of Chronos. So those two things I think were the interesting stuff. Let's go back and just look at the alerts the way they are without changing anything. We expect to see a lot of noise here, and I think this is where our learning takes a different form. A lot of people just go and attack machines on VounHub and they like it, and they end there. We like to see what noise we generate as the attackers on the network. We like to see the packets going through the network, and this is the traffic that we did. This is interesting. There's some Easter egg stuff here. This is probably because we have a default page. When you see some of these Easter egg stuff, it's probably because someone installed a website, they didn't change the default page. But the ones that shows that we did the ID command are very interesting. All right, so let's look at those. This one is the one that says Unicode Directory Transversal. It's either Nicto or it's actually something interesting. I ran Nicto earlier against this thing, so we might be seeing that. Yeah, this one is Nicto. I hope they're not all Nictos again. This one is response of the ID command. So this one should show us, oh, this is 8020, port 8020. That's when we ran the final exploit. So this is the actual rule that fired. And as you can see here, we have the commands that the attacker ran with the export term stuff. The command, you can tell it from here in the network.decoded. So we caught both reverse shells that we did. So we can say for sure the attacker got in as www data. Then afterwards, they did lateral movement and they got back in as Emira, and they ran the command clear. So if Emira has any SUIDs or pseudo permissions, we know the attacker succeeded from this here. All right. This one is, well, it's the same. The return of the command ID on 8020 was caught again. But this time, what was it? Yeah, it's probably because I ran it a couple times. And that was it. So sorry that the stream kind of broke there. I might have accidentally exited out of my screen or something. But I hope you learned something from this, and subscribe to my channel if you haven't. And then like this video so YouTube can let everybody know. Otherwise, set up this lab for yourself. Let me know if you succeed in setting it up. It's really fun. It's a great way of learning. And I feel like I'm ready for the OSCP, which is coming here in a couple of weeks. So thank you for being here. Next week, we're taking the week off. However, I will have a scheduled video that I will pre-record. So at 9 p.m. Central Standard Time, there'll be a video with me attacking a machine that will be scheduled and that will play for you. So even though I won't be here, we'll still attack a machine so we don't miss a week of attacks. So again, thanks for being here. If you haven't, please subscribe and set up your own lab. And otherwise, see you in a couple weeks.